Alright, so this is a separation of variables question from openstacks.org, Calculus Volume 2, Exercise 4.3, Separable Variables, question 138. It's a nice one that gives you kind of the full gambit of separation of variables. We've got some partial fractions, we've got some sneaky little algebra, and we've got some logarithms that we can contend with. So let's have a look at it and see how it goes. So the first thing I want to do is rewrite it in a dy dx form. So that's a matter of okay. So I haven't changed anything there. I've just been explicit about y prime being dy dx, and that's fine. Now I'm going to move all of the y's to the left-hand side of the equation and leave the x's where they are. So that gives me 1 plus 2y dy dx equals 2x. So I've separated the variables here. So I've got all the y's here, all the x's here, and this is what's going to allow me to anti-differentiate this. So now I'm going to take the integral dx, and we'll get some nice kind of chain rule behavior that allows us to do our anti-differentiation. So if I take the integral 1 on y, 1 plus 2y, dy dx equals the integral of 2x dx. And then you'll see that the dx here cancels, and I've got this nice integral in terms of y and integral in terms of x. Now I'm going to need to do something about these guys. So let's do a little aside here, and let's separate these into its partial fractions. So I get 1 over y, 1 plus 2y. I'm going to make that the same as a over y plus b over 1 plus 2y. I'm going to cross multiply. Alright, I'm going to be a little bit sneaky. I'm going to let y equal 0. Some of you will be saying, no, don't let y equal 0. We're not allowed to do that because we'll be dividing by 0. It's kind of okay. It's a bit cheeky, but we can get away with it this time. And when y equals 0, you should be able to see pretty quickly, if y is 0, a times 1 is 1. So a is 1. Alright, so then I let y equal negative 1/2, and that 1/2 comes from setting this to 0. So I'm going to be cancelling that now. So I'm going to let y equal negative 1/2. I get 1 equals b times negative 1/2. That y is negative 1/2. So I get from that b equals negative 2. So I've got my partial fractions numerators, so I can now express them this way. So I get the integral of 1 over y minus 2 over 1 plus 2y dy equals 2x dx. Alright, so I've got 1 over y. Integral of 1 over y is natural log, absolute value y. And then I've got this 1 plus 2y situation here. So I've got a nifty little rule for that. So the integral of a function's derivative over that function is always equal to the natural log of the absolute value of that denominator. And what do you notice about this? The derivative of 1 plus 2y is 2. So I have that nice log identity that I can use. So encourage you to prove that to yourself. It's kind of nice. You use a u substitution to do that. So let's do this integration. So I get the natural log absolute value of y minus the natural log absolute value of 1 plus 2y. And this guy equals x squared plus c. Alright, let's do some log laws. So for log laws here, I get natural log absolute value of y over 1 plus 2y equals x squared plus c. So now I'm going to make the claim that y over 1 plus 2y is equal to plus or minus e to the x squared plus c. And that comes from the fact that this absolute value means that I can swap that out for a plus or minus on this side. And I got this e, because if I raise this to the e and I raise this to the e, this side cancels. All right. Now, just because this is a bit untidy, I'm going to set plus or minus e to the c, which is constant, to be the pronumeral a. That's a different a to this one up here. But a, it's a nice pronumeral to use. You can use a different pronumeral if you like. So I get y over 1 plus 2y equals a e to the x squared. I can sub in the fact that y of 0 equals negative 1. That comes from the question. Y of 0 is negative 1. And that lets me say that negative 1, oops, in white, negative 1 over 1 plus 2 times negative 1 equals a. 0 squared is 0, e to the 0 is 1. Okay, so from there, I can see pretty quickly that a equals 1. Okay, I encourage you to prove that to yourself. So I get the form y over 1 plus 2y equals e to the x squared. Okay, let's tidy this up. So let's cross multiply. I get y equals e to the x squared, 1 plus 2y. I can expand that bracket. Y equals e to the x squared plus 2y, e to the x squared. I've got a y on this side and a y on this side. Let's move this guy over. So I get y minus 2y, e to the x squared equals e to the x squared. Let's move across to here. Factor out that y. And then divide. So I get y equals e to the x squared over 1 minus 2e to the x squared. And that is our solution to our original equation. Okay, thank you.